Not well? Not well, huh? I'm taking class. Don't sleep in the class. You sit in my room, aram se, sit in that sofa.
Good morning, guys. Good morning. Morning, guys. Okay, we'll start the class. So, yesterday we have stopped up to the question of NEET PYQs, right? So, we'll continue with that NEET PYQs. Okay. So, good morning everyone. So, in today's session we are going to start with the NEET PYQs where we left in the last class. Okay. So, the first question, match the column 1 and column 2 and choose the correct matches from the given choice. So, column 1 is given like root mean square. Let me check my mic. It's audible. Root mean square speed of a gas molecule. Second one is pressure exerted by ideal gas. Third one is average kinetic energy of a molecule, and the fourth one is total internal energy of diatomic gas. So now I need to match the column 1 and match the column 2 for the correct answers, right? So let me take a pen now. Yes, where's the pen? Yeah, came. Now the thing is, first one we have asked root mean square. Root mean square speed of a gas molecule. So when I see the root mean, no, is there any roots are available? First, for guess, I can take any roots are available. Yeah, the root is available here. But if anything are there, any other roots also, I need to cross check the formula first. Okay. So obviously, for the first one, root mean square speed of a gas molecule, it is Q. Okay. For the second one, pressure exerted by ideal gas. Pressure exerted by ideal gas. It is, let me write it in some other color, it is visible. A is nothing but Q and B, C, D. Okay. So if you are not getting this one, now go for the third one. So whichever option is left, we can choose that one. Okay. If you know the answer, directly you can write it. But if you are not getting now, see the some other formulas, whatever you know, and match that, and remaining you can take for that option, right? So average kinetic energy of a molecule, average kinetic energy, obviously 3 by 2 kT, right? 3 by 2 kT, it is yes. Okay. What about the total internal energy of one molecule of diatomic gas? It is obviously 5 by 2 RT. So this is R. So what is the left out thing? It is P, right? Okay. So pressure exerted by ideal gas is 1 by 3 N mv power minus 2. Okay. So remember this formula, that is root mean square speed of a gas molecule is root 3 mt by m. Okay. And then pressure exerted by gases, it is 1 by 3 N mv power minus 2. Average kinetic energy of a gas molecule, it is 3 by 2 kT, and total internal energy is 5 by 2 RT. Okay. Can we go for the next question? We'll go for the next question. Okay, we'll go. The next question, the mean free path of for a gas, which molecular diameter d and number density n can be expressed as? So this is the direct formula, no? Can you give the formula for this? Can you say which is the formula for this? It's a direct formula. Mean free path. So the answer is, the answer is option D. Option D. Where is the pen? Yes, pen came. Option is answer D. This is the answer. So it is 1 by root 2 n pi d square. Okay, this is the answer. We'll go for the next question. Yes, we'll go for the next one. Okay, the molecule for molecule of a given mass of a gas have RMS the velocity of 200 meter per second at 27 degrees Celsius and 1 into 10 power 5 Newton meter power minus 2 pressure, when the temperature and the pressure of a gas respectively 127 and 0.05 into 10 power 5, the RMS velocity. So initially what they have asked, like velocity has been given, temperature is given, pressure is also given, and for the second case like temperature and the pressure value is given, the RMS they are asking. Here the RMS they are asking, right? Second velocity they are asking. What is the formula for RMS velocity? Vrms. Yes, it is. I'll take a pen. So Vrms is equals to under root of 3RT by m. Okay. Now what are the things are given here? Velocity is given, right? First V1 is given and temperature is given. So the pressure is given. Okay. So V1 is equals to 200 meter per second and T1 is equals to 27 degrees Celsius. Can I convert it into Kelvin? It is 273 plus 27, which is nothing but 300, no? 300 Kelvin. Okay. What about the second thing? 127 degrees Celsius. T2 is given as 127 plus 273 Kelvin, which is equals to, what is the answer? It is 400, right? 400 Kelvin. What about the pressure is given? 0.05. P2, here P1 is equals to 1 into 10 power 5 and P2 is equals to 0.05 into 10 power 5. Okay, this is the thing are given in the question. So now here if you see, temperature is there, but what about the pressure? What about the pressure? Mass is given. What can I do for this question? Yes, PV is equals to nRT. PV is equals to nRT we can use, right? Yeah. So PV is equals to nRT, and one more thing, we know that like volume is directly proportional to T by P. Okay, that one will keep as it is. One more thing is like we know the relation between density, volume and mass. Now density equals to mass by volume. Density equals to mass by volume, right? Where volume will be equals to mass by density. So by using these two relations, can I write the equation for the questions? Can I write the equation for the question? Yes, V2 obviously, yeah. V2 is equals to under root of T2 by P2 divided by V1 is equals to under root of T1 by P1. That's it. So from this, no, T2, P2, T1, P1 I know, and V1 also I know. So I can find the V2 value. I can find the V2 value. It's easy, no? Now, whatever the question they have asked, I have written the given terms there, and the formula of RMS is root of 3RT by M. From this, now, like density, mass and volume relation I know, and the temperature and pressure relation I know. Yes or no? Like PV is equal to nRT. From this volume, no? From this volume, I can substitute the value of V is equal to M by rho. So by the substitution, I will get the formula V2 is equal to root over T2 by P2, and V1 is equal to root over T1 by P1. So I hope you got the thing, whatever they have asked in the question, right? We'll go for the next one. Yes, we'll go for the next question. The next question is, yes, the ratio of frequency of fundamental harmonic produced by an open pipe to that of the closed pipe. This closed one, okay? This one is closed. Yes, it's not a dosed pipe, it's a closed pipe, okay? Spelling mistake. This is closed pipe having the same length. So I need to find the ratios here now. Frequencies ratio. Length is same now. Okay, length is same. So the formula is, what is the formula for the frequency of open and closed pipe? Open pipe and closed pipe. Can you give the answer? Yes, it is F for open, like frequency of open is nothing but V by 2L, and for closed it is V by 4L. That's it. They have said that length is same. No, length is same. Now I can substitute I can take the ratios of both. What they have asked, open pipe to the closed pipe. Open pipe to the closed pipe. So F divided by F closed is equals to V by 4L. That's it. From this, I will get the ratio of the given question. Ratio of the given question. Can we go for the next question? Yes, we'll go for the next question. A pendulum is hung from the roof of a sufficiently high building and is moving freely to and fro like a simple harmonic oscillator. The acceleration of the bob of the pendulum is 20 meter per second square at a distance of 5 meter from the mean position. The time period of the oscillation is, they are asking about the time period now. Okay, time period, we know that 2 pi by omega, no? 2 pi by omega is the time period. So what, yeah, I can take, the formula is T is equals to 2 pi by omega. Okay, like pi is constant, like 22 by 7, or else I can take 3.14 also, right? But what about the omega? So what are the given things? First we will write here. Acceleration is given. Acceleration is equals to 20 meter per second square, and distance is given. Distance is, let me take x is equals to 5 meter. So from this, no, distance and acceleration I know. From this I can write the formula A is equals to omega square x, right? A is equals to omega square x, where I will write here A is equals to omega square x, where omega square is equals to A by x. So what is A here? 20 meter per second square. 20 divided by, what is x? It is 5. So 1s are and this 4s are. So omega will be equals to 2. Omega will be equals to 2. Now take this omega and substitute in this equation. T is equals to 2 pi by omega. T is equals to 2 pi by 2, which is nothing but it is pi seconds. The answer is pi seconds. Where is the answer? Option 2. Option 2 is the correct answer. Option 2 is the correct answer. So what is the formula we have learned? A is equals to omega square x, like acceleration, omega and x. T is equals to 2 pi by omega. Okay, this is the formulas we learned in this question. Can we go for the next question? Can we go for the next question? Okay. A tuning fork is used to produce resonance in a glass tube. The length of the air column in this tube can be adjusted by a variable piston. At room temperature of 27 degree Celsius, two successive resonances are produced at 20 centimeter and 73 centimeter of column length. If the frequency of the tuning fork is 320 Hertz, the velocity of sound in air at 27 degree Celsius is, okay, I need to find the velocity. The question is asked about to find the velocity, right? Where is the pen? Yeah, it's came. So to find the velocity, I need to find the velocity. Okay, what other things is given? Frequency is given, f is equals to 320 Hertz, right? And then two successive resonance. Let me take the L1 is equals to 20 centimeter and L2 is equals to, what is this centimeter? Like 73 centimeter, no? 73 centimeter. Can I convert it into meter? Right? It is 10 power minus 2, right? 10 power minus 2. So whenever you are doing, convert everything into same units. That's the important thing. Okay. Now, what is the formula? What is the formula? F velocity is equals to F into lambda. Okay. So what about the lambda? It's two successive resonance, no? Two successive resonance. So it is off of the wavelength. Like successive resonance, no, it's off of the wavelength. So L2 minus L1 is equals to lambda by 2. Okay. So lambda will be equals to 2 times of L2 minus L1. What about L2 here? L2 is 73. 2 into, okay, I should change everything into, yes, it is meter. So let me minus it, like 73 minus 20, it is 53. 53 into 10 power minus 2, that is meter. Okay, this is about L2 minus L1. So it is 0.53, right? 0.53. So what will be the value of lambda? It is 1.100 and 106, no, so 1.06. Now V will be equals to, frequency is 320 and lambda is 1.06. When I multiply this, what answer I will get? What is the answer for this question? Like only the calculation is left out, right? Yes, it is approximately, we will get 339 meter per second. This is the answer. Okay. Okay guys, we'll stop up to here. We'll see remaining questions in the next session. Okay. Until then, bye bye.